Okay, this is section 8.5, functions of angles and some fundamental identities. Okay, so we're going to define an angle as like this, where it's a point in space, creates an x and a y point, right? That's our point in space. And if we are put that on our coordinate plane, we have an x and a y axis. And the angles we've done on the coordinate plane always start with the 0 over here, going to the right on the x-axis. And wherever the other angle is, the terminal side, they call it here. If we draw a line from our point to the origin, we're going to create an angle. The angle that's what they've outlined here in blue. But we can also make, give us the x coordinate and the y coordinate for that point, creates a right triangle. So from that right triangle, we can figure out using Pythagorean theorem, x squared plus y squared equals the hypotenuse squared, or in this case, they call it r squared because it's kind of like the radius of a circle if we were talking about angles. And r is always going to be positive, right? It doesn't matter what the value of x and y are. If they're both negative or whatever, whenever we square those, it creates a positive value, and we always get r is always positive. Okay, so using that definition, our six trigonometric functions, our sine is y over r, or it's the opposite over the hypotenuse. Cosine, adjacent over hypotenuse, and tangent is opposite over hypotenuse. And the cosine, the cosecant, the secant, and the cotangent are all reciprocals of the respective functions. Okay, so if we know what the position is it goes through, we can figure out what the ratios of the sine, cosine, and tangent are, and then their reciprocal functions also. So if it goes through this function, this point here, -3, -4, we can figure out what r is using Pythagorean theorem, or just x squared plus y squared gives us 5. Then we can figure out all these ratios. -4 over 5 is the sine. -3 over 5 is the cosine. -4 over -3 gives me the tangent. And since they're both negative, tangent ends up being positive. And then the cosecant, secant, and cotangent are all the reciprocals of those functions. Okay, so the trigonometric functions could be found any point on this line. It doesn't matter how long r is. R doesn't have to be 1 like we've been doing the unit circle. R can be any length we want, but the ratio is still going to be the same. The ratio of the opposite over the hypotenuse, the ratio of the adjacent over the hypotenuse, all these trig ratios would be the same as if our hypotenuse was 1. And so we get the same values for all the angles, no matter how big or what point this is on the triangle. So they've gone through that on this little chart here. And the reciprocal functions, we've already explored these. Sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals of each other. And tangent and cotangent are reciprocals of each other. We've gone through these already. So they have a problem like this. Find the sine of theta if cosine of theta is negative square root of 12 over 2. Okay, remember you can't just do 12 divided by 2 here because of the square root. Okay, but you can just flip over this 2 and 12 and you'll get this. They did it like that. There's the extra step they did. But you can just do that, and then they kind of cleaned it up a little bit and put the radical, the square root on top. And so you can make it look like that also. They usually have it look like this with the square root on top. And now we're going to talk about the signs and ranges and everything in quadrant 1. R is always positive. Everything in quadrant 1 is positive, so all the values there are going to be positive. And you can look at the chart here. See, all the values for all the functions are always positive in quadrant 1. In quadrant 2, we've got the y positive, but the x negative. So all the things that just have to do with y and the hypotenuse are positive. So sine is positive, and it's reciprocal. The cosecant is positive. Everything else is negative. In quadrant 3, everything is negative. The x is negative, the y is negative. That creates negative values everywhere except for tangent and cotangent because they're x divided by y or y divided by x, and those two negatives make a positive there. In quadrant 4, the y value is negative, the x value is positive. So cosine is going to be positive, and of course its reciprocal is also going to be positive. So you'll have some problems like this down here at the bottom. Example, find the quadrant when it satisfies these two conditions. The sine is positive and the tangent is negative. Well, if you have this chart, it's pretty easy, right? So sine is positive here, but tangent's negative in quadrant, positive in quadrant 1. So that doesn't work. The only other place that sine is positive is quadrant 2, and sure enough, tangent's negative there, so it has to be quadrant 2. It's the only one that meets that requirement. And we're going to talk about the ranges in here, so I'm going to skip that one, go to this one. This is the sine. We've already done this for the basic sine function. It has a range of -1 to +1. Cosine the same way. Secant and cosecant are reciprocals of that, so they don't have any of these values, but they have all the other values in the real numbers. So they're all, the secant is anything from -1 down to -infinity to -1, and it's also everything from 1 to infinity. Same thing with the cosine, the cosecant. Same values, okay? They have that. They have all the rest of the values that sine and cosine don't have because they're reciprocal functions. And here it is on this page, a nice little synopsis of what the ranges of each different angle can be. Okay, so this is just the ratios. These are all the sine, cosine, tangents are always going to be in this value ranges. Okay, so you have 3 problems here. Can they work? Is it possible? Is it impossible? So look at them for a minute. Look at the 1, 2, 3 up there, and 2 of them are not possible. So can you figure out which 2 are not possible and which one is? Pause the video and take a stab at it. Did you guess right? Well, this square root of 8 is greater than 1, so that's not going to work. Sine has to be between 1 and -1. Tangent, yeah, that one does work. Even though it's a big number, we don't normally see that, but it could be what the angle of tangent equals. And secant looks like a perfectly good number, except that secant can't be in that range from -1 to +1. It has to be less than -1, -1 or less, or 1 or more. So it's not going to work. And if we take this basic function, a basic Pythagorean theorem, and all these definitions of sine, cosine, and tangent we've gone over, and we do a little algebra manipulation on it, we divide everything by r. That gives us 1 on the right here, and it gives us x over r squared and y over r squared. Well, x over r is just my cosine. Y over r is my sine. So cosine squared plus sine squared equals 1. So if we square the cosine of an angle, we add the sine of that same angle, square it, square both of those, we're going to end up with 1 all the time. It doesn't matter which angle we do. That's going to be an identity. It always equals 1. And it's more commonly written like this, where sine squared theta plus cosine squared theta equals 1. But it means that the cosine of the angle is squared and the sine of the angle is squared. It's written like this, but it means this. Okay, so we can do a couple other identities if we divide it by the other variables here. In this case, we divide by x. We get y over x is the tangent, r over x is the secant, so we get this identity. And if we divide by y, we get this cotangent and cosecant identity. So they're called the Pythagorean identities. They're all up here at the top. And you have some problems where you need to use these to figure out what's going on. Okay, so the first one here, they say the tangent is 4 over 3, and the angle's in quadrant 1. So we want to find the sine and cosine. Well, we know the sine and the cosine in quadrant 3 are going to be both negative. Tangent is going to be positive, but the other functions, except for cotangent, are going to be negative. But we can figure out that the secant, what that equals, so 4 squared over 3 squared. Okay, so that's 16 over 9. So we do 16 over 9 plus 1. That means that we have to change that 1 to 9 over 9. So 9 over 9 plus 16, so it's 9 over 9 plus 16 on the top gives us 25 on top and 9 on the bottom. Okay, so that's still everything, but that's equals secant squared. So if we take the square root of that, square root of 25 over 9, we get 5 over 3. But we know it has to be negative because it's in quadrant 3, so that's where the negative sign comes from. And then to get the cosine, we just flip it over, right? 3 over 5. Okay, so the same thing works for sine squared. You get 1. Well, we know from the identities, right, the sine squared equals 1 minus cosine squared. So they do that. So that's 1 over 5. So it's 5. This would be 25 over 25 minus or plus. So yeah, when it's squared, it's just, that makes it positive. So it's 25 minus 9 is 16 over 25. When we square all this and do the right matching of the thing. So sine is going to equal 5 over 4. And again, we have to put the negative there because it's in quadrant 3. So 5 over 3 and 4 over 5, both negative on that one. Okay, so this is kind of deriving where the sine and the cosine come from, I mean the tangent and the cotangent come from. If we take sine over cosine, I've said this already, that this is what they equal, and this is the algebra behind it here. If we take this, which is the sine, divided by this, we multiply by the reciprocal, the r's cancel out, we get y over x, which is tangent. Similar thing gives me cotangent, so sine over cosine equals tangent, and cosine over sine equals cotangent. Okay, so that's the end of the slideshow. Answer the questions on the form below, and I'll see you guys in class tomorrow.